Welcome back from the ad break, and let's continue with our lesson. So we are going to be looking at the first part of our lesson, which is the linear graphs, where we are going to be looking at increasing graphs and decreasing graphs. Let's first look at the standard form of a linear graph. We have that form of y is equals to mx plus c. So when we're looking at the y value, that would be the output value. Then we are looking at m, and that is for the gradient. Then next we have the x, which is of course our input value. And lastly, we have the c, which is our y-intercept. And of course, we're going to see how this equation, or how all of these definitions, they go into our equation. Let's look at the first graph that we are given here. Now this graph is given the equation y is equals to x. Thinking about our standard form, y is equals to mx plus c. What do you think is the value of m? Now remember, our standard form was y is equals to mx plus c. But we have been given y is equals to x. So what do you think is the value of m? If you are thinking of 1, then you are absolutely correct, because we know that when we have x like that, it is only 1x. So that means that the coefficient of that x there is 1. Then, what do you think is the value of c? So we know that the value of m is 1 according to our standard form. What do you think the value of c is? Now, if we are looking at our equation that we've been given, the value of c is the one that comes after our gradient with our input value. And in this case, we have nothing there. So that means that our value of c is a 0. And remember, the value of c is also the y-intercept. So let's look at our equation there, since as well we know that m is equals to 1 and c is equals to 0. Now the equation that we've been given there is y is equals to x. What does this mean? It means that when the y value is 1, the x value is also 1. So that coordinate there would be a 1 and a 1. The same value, y, because y is equals to x. That means the input is the same as the output. We go over to another point. That means when y is 2, then x is also 2, and that is where that coordinate meets. So that means that coordinate would be a 2 and a 2. It's even the same with the negative numbers. It means that if y is negative 3 and x is also negative 3, and that is where those two values meet, and that coordinate would be a negative 3 and a negative 3, just to show that y is equals to x. So when we are looking at this graph, we say there that it is an increasing graph. And why do we say that it is an increasing graph? Now remember, when we are looking at our x values, we are going bigger when we are moving to the right. So from negative 3, if I move to negative 2, I am going bigger, and if I move to negative 1, it's becoming bigger. Those numbers, I move to 0, those numbers are becoming bigger. So as I am moving from the left to the right with my x values, then my y values are also going up. So we were at negative 4 there. As soon as I move to negative 3, my y values are also increasing. As soon as I move to negative 2, my y values are also increasing. So as we are increasing in the x values, we are also increasing in the y values. And this is why this is called an increasing graph. But now, what would a decreasing graph look like? We have here the graph y is equals to negative x. Now remember the standard form. Y is equals to mx plus c. What do you think is the value of m here? If you are thinking that m is equals to a negative 1, then you are correct, because the coefficient of that x is a negative 1. What about c? Yes, c would be a 0. Why? Because we can see that there is no y-intercept, or sorry, the y-intercept for this graph is a 0. Remember what a y-intercept is? It's where our graph crosses or intersects the y in the y-axis. So that is at 0, as we can see with our graph. But now it is a decreasing graph. And why do we say it's a decreasing graph? We can see there that when I am at -3, for the x values, my y value is at a +3. So that is -3 and a +3. But as I am increasing in x values, can we see how my y values are becoming smaller? I am no longer at 3 for the y value. I am now at 2 for the y value. As we can see, that coordinate there is a -2 and a 2. Then we go over to another value where we have x as the -1, and as we can see, we have moved from the output being a 2, now the output is a 1. So our output values are going down. So here I have -1 and 1. The output values, it was a 3, then it moved down to 2, and it moved down to 1. And as we continue, it also continues moving down. And because our output values are decreasing, then that is why this is called a decreasing graph. Now let's look at a linear graph where the formula is y is equals to 2x. Can you tell what the value of m is here? If you are thinking of 2, then you are absolutely correct. And as we can see again, our c is 0 because our y-intercept is at 0. Now when we are looking at this graph, is this an increasing graph or a decreasing graph? Let's look at when we increase in the x values, what happens to the y values. So when we move from -2 and we go to -1, what is happening to our y values? So from -4, my y value is now at -2. Then we move on to 0. So now we have moved from -2 to 0. We move on to a 1. What is happening to my y values? My y values, as I can see, they are going up. So we started at -4, but now we are at 2, and that of course continues indefinitely. But what is happening to our graph or our y values? Our output values are increasing. Therefore, this is an increasing linear graph. What about this next graph over here? Is it an increasing or a decreasing linear graph? So as we can see here, what is our graph doing from left to right? So as we are moving along those x values, and as we are increasing those x values, our y values are also increasing, because when we are moving from the left and we move over to the right, we can see that our graph or our y values are increasing, which means that this is an increasing linear graph. What is the value of m here? Yes, m is equals to a 5. And take note that it is a +5, and it gives us an increasing function. Sorry, an increasing graph. And what is the value of c here? Yes, the value of c is 0. As we can see, remembering our standard form, mx plus c. Let's quickly go to an ad break, and then we'll see you just now.